Today we'll be working on lesson 4.2, Nth Roots. Before we start solving some practice problems, I would like to discuss with you what does Nth root mean. So let's start by that. So far we've been familiar with the square root. For example, the square root of 5. Usually we do not write the index to, so whenever you see something like this, you know then it is the square root of 5, and even though we don't write the index, we know that the index is going to be 2, but we don't write it down. And that's why it's called a square root. Now, in this lesson, we're going to learn how to simplify different types of roots, like cubic roots, fourth roots, and so on. So that's why it's called nth root, because the index is going to be changing, and we're going to learn how to simplify different types of radicals. In this tutorial, I'm going to be working on the even numbers in the practice sheet. So let's start on number 2. When you have something like that, you know that this is a square root. And you know that the index, or the little number on the outside, is going to be 2, even though we don't write it down, but we know it is 2. Now, to work on something like that, you can think of it separately. You can think of the number and try to simplify the number first, and then you can take each variable alone. So let's start with square root of 16. We do know that the square root of 16 is 4. So that was easy. This one was easy. We didn't need to really do the factor tree or prime factorization to decide what or how to simplify square root of 16. Now let's think of the square root of x to the 4th. Now, if the power of the variable is 4, and as you can see, it is divisible by the index that is on the outside, you can directly know that the answer of square root of x to the 4th is x to the power 4 over 2, which is a 2. So, if the power of the variable is divisible by the index, then the answer, or how to simplify this variable, is by dividing the power by the index. And then you will get 4 over 2, which is a 2, and that would be the answer. And in this case, you can also simplify y to the 6th. As you can see, 6 is completely divisible by the index 2. So I can write it as y to the power 6 over the index, so the power over the index 2, which is a 3. So 6 is completely divisible by 2, and then your answer is going to be y to the 3rd. So the answer of square root of 16 x to the 4th y to the 6th, you can simply say that the square root of 16 is a 4, that the square root of x to the 4th is x to the 2nd, since 4 divided by 2 is a 2, and then the square root of y to the 6th is going to be y to the 3rd, since again, 6 is completely divisible by the index 2. 6 divided by 2 is a 3. So that is an example of how to simplify different variables and a number under the square root. Now, is there another way to do that? Definitely. Now, this is the fastest method to do it, but I'm going to show you a different way if you didn't like this method. So let me erase everything so I can start on a different method. Now remember, you don't even have to write the index 2, but you do know that it is 2. So let me erase that. Okay, so how do you think of this one? Square root of 16 x to the 4th y to the 6th. You can simply basically go to the radical over here on your calculator. You can go to second the square root and find the square root of 16 to be 4. Okay, so we know that square root of 16 is 4. Now, if you want to think of x to the 4th by itself, you can't really put the variable over here on the calculator. It will not give you the right answer. So you can think of it this way. X to the 4th, it means you are multiplying 4 x's together. Okay? It's x times x times x times x. Since the index over here We know, even though it's not written, we know it is 2. This is a square root. Then anything on groups of 2 will leave the radical. So I have one group of 2x's and another group of pair of x's. So how many groups do I have? I have 2 groups. Group number 1, group number 2. So it means that x squared is leaving the radical. So x, 1x, because there's one group is leaving the radical, and another x is leaving the radical. So I have x and x leaving the radical, which is equal basically to x to the second. Now y6 means I have 6 y's being multiplied together. And remember, since the index is 2, then anything groups of 2 or any pairs will leave the radical. So I have 1, 2, 3 pairs. So basically 3 y's will be leaving the radical. So y times y times y is y to the third. So that is another way you can think of it. You can basically put them in groups, and depending on the number of groups you have, this is how many y's or how many x's will be leaving the radical. So let's try to do another example. Hopefully this will be then clearer. Okay, now over here, as you can see, we have a square root as well. So I'm going to use the first method to solve this. Square root of 16, as you can see, is 4. We've done this before, and we know that the index here is 2. Remember that. Now, if I want to do the easy method, I can just look at the variable, and I see that the power of the variable is divisible by the index. 2 divided by 2 is a 1, so I know then x to the first, or just x, will be the answer. Now y to the 10th. Now I can look at the power. I can see that 10 is completely divisible by 2, so 10 divided by 2 is a 5. So the answer would be y to the 5th. Since the square root of 16 is 4, x to the second, 2 is completely divisible by 2, and y to the 10th, 10 is completely divisible by 2. Nothing is left under the radical, so the radical just disappears. And the answer would be 4xy to the 5th. Now remember, you have a negative in front of the radical, so you just copy it down. So my answer would be negative 4xy to the 5th. Now, in these two examples so far, the power has been completely divisible by the index. So let's hope that the second example, it is not. So let's move on to number 6 now. Still, it is divisible. So far, these have been easy examples. So square root of 49. What's the square root of 49? Now you should know that the square root of 49 is 7, since 7 times 7 is 49. Now remember, this is a square root, so I know that the index is 2, or the little number on the outside of the radical is 2. Now, the power of the x is 10. 10 divided by 2 is a 5, so it's completely divisible. Now, y to the 8th, the power 8 is completely divisible by 2, it's a 4. So y to the 4th is your answer. Since everything is completely divisible, the radical goes away, and your answer is 7x to the 5th, y to the 4th. Now let's move on to number 8. 4th root of 81. Now, if I want to do this without a calculator, I'm going to think of the 81 by itself, okay? And if you cannot, if you didn't already figure this out, this is like basically 4 3's multiplied together. It's 3 times 3 times 3 times 3 is equal to 81. But if you didn't see that, you can do the factor tree. So what multiplies to give you 81? 9 times 9. Now what multiplies to give you 9? 3 and 3. Now every time you get a prime number, just circle that, and then I know that the prime factorization of 81 is 3 times 3 times 3 times 3. Okay, so 81 is 3 times 3 times 3 times 3. Now what is the index on the little number on the outside of the radical? It's a 4. So it means anything in groups of 4 will leave the radical. So let's see. I have 1, 2, 3, 4. So I have one group of 4 terms. So it means I have one group. So only 1, 3 will leave the radical. Since nothing is left, so then the radical goes away. Nothing is left under the radical. Everything is grouped. Now, so that would be your answer. Now, how do you do this on the calculator? Now, if you go to math, Mhm. So once you go to math, okay, you'll see, you look at number 5, it's x square root or x radical. You see that? Now, if you have an index that's greater than 3, like 4 for example, you have to press 4 first, and then you press math, and then you press 5. So the calculator understands that the number you pressed before you pressed math is going to be your index. So 4th root of 81 is equal to 3. Now this one, the 81 was completely simplified, as you can see. Now the calculator does not always help you if the number under the radical is not completely simplified. Then you have to actually do the factor tree and group them. But this is how you would do it on the calculator. Now let's move on to number 10, cubic root of -8. Now, if you have an index that's odd, then it is possible to have a negative under your radical. And then then the answer will be a negative answer. Now, if I want to do the factor tree to simplify 8, I know already that 2 times 2 times 2 equals 8. So I know that the index is 3, so anything groups of 3 will leave the radical. As you can see, I have one group of 3 2's, okay, so one group of 3 terms. So then, since I have one group, only 1 2 leave the radical, so my answer is -2. So again, remember, if you have an odd index, it's possible to have a negative under the radical, and the answer will be negative. Now, a cubic root of 8 is a 2, because as you can see, the 8 is made up of one group of 3 2's, okay? So if you want to do this on the calculator, you can directly go to math. As you can see, you have an option for the cubic root, so I'm going to press number 4. I directly see the cubic root. I can press -8, and I can see that the answer is -2. Now let's move on to number 12. Cubic root of 27x to the 9th, y to the 3rd. Now you can think of each one separately. So first of all, let's think of the cubic root of 27. Now 27 basically is 9 times 3. Circle the 3. And 9 is 3 times 3. So as you can see, the prime factorization of 27 is 3 times 3 times 3. Now since the index is 3, so anything in groups of 3 will leave the radical. As you can see, I have one group of 3 terms, 1, 2, 3, okay? So since I have one group, only 1 3 will leave the radical, and you can do that on the calculator if you want to. You can go to math, and then you can click on number 4 because you have the option for the cubic root, and you can just enter 27. So cubic root of 27 is 3. There you go, and we already found it, okay, doing the algebraic way. Now remember, like we did before, we can do the same thing over here, and as you can see, the power of the variable is completely divisible by the index. 9 divided by 3 is a 3, so then x to the 3rd will be your answer. Now let's look at the y. The power of the y is 3. 3 divided by 3 is a 1. So again, it's completely divisible by the index. The power is completely divisible by the index. So your answer is going to be 3x to the 3rd y, and that would be it. Now, remember, if you don't like this method, you can do the other method, which is basically just writing down all the x's and all the y's and grouping them in groups of 3. And I'm going to do, so that's the answer, but I'm going to do now a second method. So remember, I have cubic root, so I'm using a different method of 27, x to the 9th, I think, y to the 3rd. Let me double check. Yes. Now we already did 27, and we know that the answer of cubic root of 27 is a 3. Now for the x, if I want to simplify that, x to the 9th means I have 9 x's. Now since I have an index of 3, it means anything groups of 3 will leave the radical. So that's one group. That's a second group, and that's a third group. As you can see, I have three groups. So x to the power 3. Okay? Now let's move on to y to the third. It means I have 3 y's. Again, since the index is 3, anything groups of 3 will leave the radical. So that, as you can see, I have only one group of 3 y's. So only one y will leave the radical. So y to the first, which is 3x cubed, y cubic root of 216 p cubed 8 q to the 9th. Okay, so now let's think of 216 first. Now, if you want, you can directly check the calculator to see if this will give you an answer. So let's double check. Let's go to math. And you can directly choose option number 4. Cubic root of 216 is a 6. So it's completely simplified. Okay, so the answer is going to be 6. So it means that 6 times 6 times 6 is 216. Okay? Now, again, we can do the first method of dividing the power by the index. So 3 divided by 3 is 1. So now I have 6p to the first then. And if you look at the q, the power is 9. 9 divided by 3 is a 3. So q to the third. And that would be my answer. Again, you can write all the p's and all the q's and do groups of 3 to know the answer, but I think this is easier. Now let's move on to number 16. Square root of 75, x to the 7th y. Now I like this example because it's not everything is going to be divisible by the index. So now what do we do in this case? So now what you can do is try to simplify the number first, and then the x, and then the y, okay? And remember, if it's square root, it means you know that the index is going to be 75, okay? So let's try, first of all, to see if square root of 75 is an answer that I can use. So you can press second, x to the second, I get the square root. Now what's square root of 75? As you can see, it's a decimal answer, so the calculator did not help me in this case, but you can, so you need to do the factor tree. What multiplies to give you 75? So since it has a 5, you can think 75 divided by 5 is what? Because you know it's divisible by 5. As you can see, it's 15. So 5 times 15 would give you 75. 5 is a prime number, so circle that. 15, it can be simplified to 5 times 3. These are prime numbers, so circle these. So the prime factorization of 75 is 5 times 5 times 3, okay? Now, the index is 2, okay? So anything groups of 2 will leave the radical. As you can see, I do have a pair of 5. So it means I have one group of 5, so only 5 to the first will leave the radical. Only one 5 will leave the radical. The 3, however, is not in any group, so it's going to stay inside the radical. So I'm going to write over here 5, and I'm going to create a square root. I'm going to keep 3 inside. So as you can see, when you do the prime factorization, if you do have a group of 2, it leaves the radical. If you do not, it stays inside the radical. So as you can see here, not everything is going to be completely simplified. So now let's think of x to the 7th. X to the 7th, it means I'm going to have 7 x's. Since the index is 2, then anything groups of 2 will be leaving the radical. So I have one group, a second group, and a third group. So 3 x's will be leaving the radical. So I can write x for the first group, x for the second group, and x for the third group. So x times x times x is x to the third, okay? Now, as you can see, there is a lonely x that is not, sorry. You have one lonely x that does not belong to any group, so that is going to stay inside the radical, okay? Now let's think of the y. Now you only have one y, so it's not part of any group. So let me remove the... Okay, so as you can see, I have only one y. and it's not part of any group. There's no a group of or a pair of y. So as you can see, this one's going to stay inside the radical. So your answer is going to be 5x to the third square root of 3xy. Let's move on to number 18. As you can see, you have square root of 50, c to the 8th, d to the 16th. Now what you can do is you can simplify the number first, then the c, then the d. So let's think of the number first. Square root of 50. Let's try that. Most likely it's going to give me a decimal, but it's worth a shot. As you can see, it's a decimal. So I need to do the prime factorization to see what part of 50 will be leaving the radical. So what multiplies to give you 50? 5 and 10. Circle the 5. What multiplies to give you 10? 5 and 2. Circle the 5, circle the 2. So the prime factorization of 50 is 5 times 5 times 2. Now since it's a square root and the index is 2, anything in groups of 2 will leave the radical. So as you can see, I have a pair of the 5. So it's one group. So only 1 5 will leave the radical. As you can see, I do not have 2 as being part of any group, so the 2 is going to stay inside the radical. Now, if you look at the c, you can write down all the 8 c's, or you can simply see that the power is divisible by the index. 8 divided by 2 is a 4, so it's completely divisible. So your answer is going to be c to the 4th. Okay, so the c completely leaves the radical. Now as for the d, 16 is completely divisible by 2. 16 divided by 2 is an 8. So then the answer would be d to the 8th. Okay. Now the reason why I wrote it behind the 5 is because I don't have a space after the c. I can fix the answer in a minute. So as you can see, the c completely left the radical because the power is divisible. The d completely left the radical. Only the 50, part of the 50 stayed inside the radical, which is the 2. So your final answer is going to be 5 c to the 4th d to the 8th square root of 2. And that would be your answer. Now let's move on to number 20. Square root of 24, x to the 2nd, y to the 14th. Now let's find square root of 24. Now I can directly know that it's not going to give me a whole number if I try to square root 24, so I need to do the prime factorization. Now what multiplies to give you 24? 2 and 12, circle the 2. What multiplies to give you 12? 6 and 2, circle the 2. What multiplies to give you 6? 3 and 2. So I'm going to now write down the prime factorization for 24. As you can see, it's 2 times 2 times 2 times 3. Now, since this is a square root, the index is 2. So anything groups of 2 will leave the radical. As you can see, I have a pair of the 2. So only 1 2 will leave the radical. Now this 2 is not part of any group, so it's going to stay inside the radical. This 3 is not part of any group, so it's going to stay also inside the radical. Remember, we multiply them. So basically 2, which is the lonely 2 and the lonely 3. 2 times 3 is a 6. We're going to put them now in a minute inside the radical. Now, if you look at the x, the power of x is 2. The power is completely divisible by the index. 2 divided by 2 is a 1, so x to the 1st. Now if you look at the y, the power of the y is completely divisible by the index. 14 divided by 2 is a 7, so y to the 7th. So my final answer is going to be 2x. I don't have to put the power 1. Y to the 7th, and inside the radical I'm going to have 2 times 3, which is a 6. And that's going to be my final answer. Now I do hope this tutorial was helpful. Please go ahead and try the odd numbers on your own.